Good morning, everyone. Hope we're all keeping well. Glad to see us up and at it already. This is actually fantastic so far, so keep it up. Today, guys, is the last day of that original week 4 timetable that I sent out. So I want to say that I'm going to post up a new one today, and it's just a 1 week timetable, and it'll take you up to Friday, okay? Because it's a bit busy, I thought, well, we'll do a separate timetable just to get us to the end of the week, to get us to Friday. And then from next Monday, I'll post up a new one, and that timetable will take you all week. I think that's the way I'll do it anyway, and we'll just do it 1 week timetables at a time. Although some of the work may fall over 2 weeks, okay? So again, there's a couple of projects and stuff that we have, and some of them I plan to maybe do some sort of Zoom groups or something like that. So I plan to separate you into groups and let you try and get used to team working and trying to organize yourselves within a team. I think that's a really key skill to have when you go to secondary school, and if you have that, or you have that ability to organize and self-direct yourself on a group task, you're going to be years ahead of where you should be. So I'm going to give you a chance to do that with some of the work tasks that we have coming up. Also on top of that, we're going to set some assessments as well. The assessments aren't, they're not like where the scores are going to be carried over to your school as usually happens with the drum conras. Instead, I'm just going to set assessments. They're like checkpoints for yourselves. They're not really for anything else. They're just like your own little benchmarks for yourself, okay? And you'll have an arithmetic one, which is just basic calculation. You'll have one of them each week, I think on a Wednesday. On a Friday, you'll do a reasoning and problem solving maths as well. Okay, so that's where we have to use those calculation skills, but with a bit of detective work to figure out which calculation skills. Okay, so that's sort of the Wednesday and Friday maths covered each week. Okay, so by my calculation, you're going to have about 5 of them to do, I would say. Okay, so 5 of each. So what your aim is to try and really smash your score week on week. Okay, a bit like beat that challenge on a Friday. Okay, you're really trying just to beat your score each week. As long as you're making the improvements each week, fantastic. Now, in between those 2 assessments, you'll notice that we're almost at the end of our Cracking Maths book. We only have pages. By Friday, you will have finished this book, okay? Which, in my terms, as far as I'm aware, makes you one of the fastest Year 6 groups to finish that book, okay? So you'll be one of the fastest to actually have that finished. Usually the Year 6s take a wee bit longer, but we've smashed through it. We've been really good with our maths all year. So by Friday, you'll have finished that book. And from there, what we need to do is spend a bit of time just going over each of the areas. So to help us with that, between each assessment week, you're going to have a revision booklet, okay? And the revision booklet will basically stick on a theme each week. So again, there's about 4 or 5 weeks left. So between each week, you'll have a revision booklet on a particular theme. I want you to work on that in between each assessment, okay? So that's how I've planned it. That we can really smash the maths by the end of the year. If you do all that, you'll be absolutely steaming ahead with the level and quality of work that you have. Okay. Then your other assessments that are going to be taking place is the revision booklet there, Jay, will be like Monday, Tuesday, Thursday. So Monday, Tuesday, Thursday of every day, you'll be trying to complete these booklets. So you'll have 3 days to try and complete a booklet. Some of you might manage it in 1 day. If you do finish it in 1 day, then you would finish the other 2 days. You're going to go back yourself and figure out some work or find some work online on the same theme. All right. So that's kind of how the maths is going to plan itself out and the reasoning for that. Okay, so Monday, Tuesday, Thursday, you'll be on a revision booklet that I'll post online. And again, if you have the luxury of printing it, fantastic. If you don't want to print loads and loads of stuff, you don't need to. Just download it, save it onto your computer, and then you can open it up and check it out each day, just moving page by page. All right, and just write answers in your maths book. So that's the maths sorted for the next to take us up to the end of term. The English stuff then as well. There is one or two writing tasks. There's a big writing task that we have to get done. I think anyway, I'm going to check the times for it. But again, it's kind of like end of year type tasks, okay? In the English then, you're also going to have assessments. You're going to have your reading assessments as well. I'm going to set one of them each week. And I think off the top of my head, I've put Thursday for reading, Tuesday for the reading assessments. So on Tuesday, you'll read assessments. I think the Mondays could be our SPAG, our grammar and punctuation and spellings. And again, I've one of them to do each week as well. And they're the exact same as maths. Try them. Some of them are quite difficult, I won't lie. Some can be. So the task or your trick is just to do it, see how you do, and then each week, just try and beat your score each week on those assessments. Alrighty? So that's our new timetable. And then I say, in amongst all of that, you've got projects, and I am also going to try and get some science experiments dished out as well that you could try at home that don't involve too much, okay? And as always, if I do set a science experiment and you don't have anywhere near the materials or anything that's needed, it's okay. Don't worry too much, all right? You can always have a look online and see is there any other at-home experiments that you could find and try out yourself, all right? The project-wise, I will explain it probably next week when we get on to that side of stuff, alrighty? So that is our plan. Let's get started for our math today. We're looking at time and we're looking at time zones in particular. So to get started, let's get ourselves warmed up. 0 top left, and today we'll play in threes. Okay, so our threes, nice and easy. Nice and easy Tuesdays. 3 times table. So 0 top left, you have 10 seconds to get as high as you possibly can, counting in threes. Are you ready? Set, go. Stop us there. Double check our numbers. We should have had 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Alrighty. So all the way up to 36 is where I'm going to stop. Let's rub out our numbers, put 0 top left. And again, you have 10 seconds to try beat your score. Okay, see how you're doing on Tuesday. Is your brain ready for the numbers or is it struggling this morning? Ready, set, go. And stop us there. Double check our numbers. We should have had 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. All right. Really well done, guys. You managed to beat your score and got all them numbers correct. Let's turn it around now. Let's go. How low can you go? How low can you go? Can you put 36 top left? 36 top left. Ooh, just beat it. 36 top left. You have 10 seconds to get as low as possible. Super Maria. Ready, set, and go. Stop us there. Double check our numbers. You should have had 36, 33, 30. 27, 24, 21, 18, 15, 12, 9, 6, 3, 0. Alrighty. Ready? 36 top left again. All them numbers stay the exact same going up as coming down. They won't change. You ready? It's 10 seconds. I really want you to try beat your score. You ready? Set, go. And stop. Double check our numbers. We should have had 36, 33, 30, 27, 24, 21, 18, 15, 12, 9, 6, 3, and 0. And that's our 3 times tables done. Alrighty. Next up. Again, just a little memory one. All we're going to do is we're playing magic boxes. So remember, magic boxes is our 100 square. And you can draw this one out. Okay. So our 100 square. What happens is I call out the number. You put the number into the middle box. And then above it is 10 less, below is 10 more, and it's 1 more and 1 less than. Okay, so you're imagining that you have a big massive 100 number grid, and wherever we pick, you're going to give me 10 less than, 10 more than, 1 more than, 1 less than. Alrighty? Should remember, we've done this a few times. Alrighty? Ready? Your number is 14. 14. 5 seconds. And stop. Okay, 14, 10 less than, should have had 4. 24, 15, 13. Happy? Let's go again. Ready? Rub out the numbers. If you have it nice and big, you can keep the boxes, and it's just a case of rubbing out the numbers each time. Ready? New number, 87. 87, new number. And stop. Double check our numbers. We should have had 97, 10 more than, 77, 10 less than, 88, and 86. Just having a look there at Jay. We used to be multiplying and dividing by tens and ones. Fantastic. If you want to keep doing that, you can keep doing it. It's probably more complicated than this. Is just nice and easy, trying to get us into the idea of picturing our number grids. Really well done, guys, if you managed to get all them numbers right. Let's go one more time. Let's open it up. Rather than having a 100 grid, what happens if we blow it right the way up, or we just presume that our 100 grid is now 100 to 200, okay? So our number is 156. So you're now working on a 100 to 200 number grid. It'll still stay the same, 10 less than, 10 more than, 1 more than, 1 less than. All right, so you're still the same game. The only difference being we're in our hundreds. Ready? Maybe 3 seconds. 3, 2, 1, and okay, hopefully you managed to get them done. Ready? 156, 10 less than is 146, 10 more than is 166, 1 more than is 157, and 1 less than is 155. Okay, so really well done if you managed to get all them. Super. All right, there we go. I think our brain is up and running. Let's go number lines really quickly. And try that one. Ready? So there's your number line. Find the gap between the start and the finish. Find out how many jumps there are. work out the size of each jump, and then start to make them. I'll give you about 5 seconds for this. 3, 2, 1, and let's have a look. Okay, for this one, 0 to 35, and there are 5 jumps. So 35 divided by 5, every jump is 7. So with that knowledge, if every jump is 7, 7, 14, 21, 28, 35. It works. All right. So 14, 28, 35. All right. I'm going to just throw it out just in preparation for some word problems and all that type of stuff. If this was your number line, sometimes you can get stuff like that, a question like that, okay, where the number line goes way beyond and that. And sometimes it causes a little bit of confusion. If you ever get this number line or anything that looks like this, it's the exact same skill that you always do, okay? The trick is this part, you block it out and you take the measurements that you do know, okay? And you just stick to the exact same skill. You know this is 0, that's 35, and you know that there are 5 jumps to get you there. And then you'd work it all out. It's 7, 7, 7. Okay? And then from there, you just continue on. So 35, 42, 49 is C. All right? So if you're ever given a number line that looks like that, it's the exact same skill. Find out where it starts, where it can finish. Okay? So although the finish is up here, you take the finishes here because this is the number that has been given to you. It's the fact. Okay? And you're always dealing with the fact. All right, so 0 to 35, and then you calculate your jumps as you would do. All right, they're rare, they don't always come up, but it's good just to make sure and address it while we're on it. Ready? Let's try it again. Just want a really, really, really hard one? Like super, super, super hard. And let's have a look. We'll go. Yeah, go for it. A and B. So there's A and B. I'll go 5 seconds. 3, 2, 1. All right, let's have a look. So number line starts at 2.5, finishes at 3. So the gap there is 0.5. It's 5 tenths. 5 tenths, okay? 0.5, 5 tenths. So if third gap in our number line is 5 tenths, 0.5, there are 5 jumps. So every jump must be 1 tenth, which is 0.1. Based on that one, then A is 2.6, 2.7, B 2.8. Well done, Alea. Okay, so 2.6 and 2.7. All right, this number line is 2.5 moving to 3. So every jump was 1 tenth, 0.1s. Okay, so we're going up in 0.1s. Alrighty. Really well done. I'm impressed you got that one. How many else got it? And really quickly, staying along that same line where we can go different numbers. Let's have a look. All right, this one going to make it quite difficult. You've got an A, B, and a C on this one. Ready? Hopefully my internet stays clear enough that you can get that signal fine and you can read the numbers. So as always, check where the number line begins, and that is -4. Where does it finish? 6. So it starts at -4 and goes all the way up to 6. So you need to work out how much that is. How many numbers is there between -4 and 6? Once you do that, calculate how many jumps there are. On this one, you can see I've got way more than 5 jumps. So we'll find out how many jumps I've got. Work out the jump size by dividing the distance by the number of jumps. That tells you your jump size. Once you've got your jump size, start calculating it. I'll give you another 5 seconds, see how we do. 3, 2, 1. Let's have a look. So you should have seen that started on -4 and we got to 6. The distance here was 10. Okay. One of the ways to always do it is from 6, you know that there must be 6 between 6 and 0. So that's 6. And from 0 to -4, there must be 4. Okay. So 6 and 4 makes 10. There are 10 jumps, so every jump was worth 1. So once we have that, let's count. -4, -3, -2, -1, 0. So A is actually 0. So we're used to having 0 at the start of a number line. This time we've actually gone past it, which is a little new. Ready? 1, 2, 3. B was worth 3. C sits perfectly in between 3 and 4. So if one jump is 1, half a jump must be half. So therefore, C, the answer is 3.5. Really well done if you got them ones. They are slightly trickier and a little bit new with this section of it. Okay, but as always, guys, it's just about being really comfortable with our numbers, knowing the size and the value of individual numbers. Once you have that, you're absolutely fine. Okay, really well done if you got that one right. As for today's work, guys, time zone. I'm not going to hold you back too much more. There's not much. I'm trying to describe time zones and that to you. Our time zones are split up to do with the sunlight and also then to do with the times of days in each countries. Okay, and now in a perfect world, I want to squash my Earth down a little bit. Okay, I've squashed my Earth down. It's not a perfect circle. I've squashed it down. In a perfect world, when time zones were kind of devised and created, essentially the thinking behind them was if we just had these lines going down. Because you'll know yourself when the sun rises and sets, daylight moves across, and then nighttime, the night sky kind of follows it, and it works in a wave. All right. And so, if the sun rises, as you're looking at it, is in the east. So sun rises here in the east, and it goes all the way over this way. Okay, so any country over this side generally will have their day start much earlier because this is where the sun is rising from. It moves in this motion. Okay, so as the sun sets here, daytime is here, and it must be nighttime over here at the opposite end of the earth. As the sun moves up and around to the west side, okay, sun rises in the east, sets in the west. Okay, so as we're looking at it, it's going to set in the west. So as the sun moves across here, that night sky is kind of looking around the back, and it's going to come then from this end. All right, so when it's daytime over here, it's nighttime at the other end. Time zones, therefore, are set up to try and keep everything nice and fair, that they're all getting the same sunlight. And the thinking was, if we just put straight lines down, we would almost have perfect time zones. However, the world is not a perfect place, and therefore those straight lines cannot exist. Okay. The reason being, imagine we had let's do a really awful version of Ireland. There's England as well, or the UK, I should say, and then absolutely awful attempt at Europe and stuff. Anyway, as you can see, if this was the case, all right, one of these lines would run straight through a country. So would that make sense? Imagine you were in Dublin and you're driving out west, and by the time you get to Kildare, which is the county beside Dublin, if you get to Kildare, you have to put your clock back an hour. Would that make sense? Wouldn't, because you're living beside each other, and if you're on the border of this line, you could be in 1 hour, you could be at 2 o'clock, and your neighbor down the road could be at 3. Wouldn't really make sense, would it? So because of that, these straight lines aren't actually straight. They curve and they go around. Okay, now they try and stay as close to their original line that's been calculated, but they do bend slightly, and they'll take the shape of a country, because there's no point in kind of generally speaking countries being apart. Now some will, but generally those lines sort of bend around a country and try and keep stuff within the time zones. Then from here, I'm going to use this because Ireland and stuff is in it, although that line will bend around. Okay, it doesn't cut through, so it bends around. So if I took this one, for example, is us. We calculate this as being 0. Okay, this is GMT, which is Greenwich Mean Time. This place has been calculated. It's in London, and I think that's where everything got calculated from. So GMT is Greenwich Median Time, and that's what we follow in Dublin and Ireland. So Ireland and the UK, and I think Iceland sits above. I think Iceland follows the same, and off the top of my head, I think there's a couple of other countries, maybe Africa and Portugal or something, I think, all follow sort of GMT. So they're all Greenwich Mean Time. That means they're all in the exact same time, okay? And it's, as I said, it's where it was devised from memory. So from here then, this is original time. Let's just see it as being original time for understanding sex. As we move towards the right-hand side, that time is going to go up. So they're going to be +2, +1, +2, +3, so on and so forth. Okay. So as you go this way, everything's going to be an hour ahead. All right. And if you think about it, as that sun's kind of coming up, remember they started their day way before us, so it would make sense that their time is obviously ahead of us if they're starting earlier. Okay. I'll come to that in a second. So as you move this side, they're all going to be 1 hour ahead, 2 hour ahead, 3 hour ahead, 4 hour ahead. All right. Then if you move the other side, if you go towards our west, or the left-hand side, they're actually going to be behind us, because remember, they haven't yet got the sun. If the sun starts here, whee, look at that, what a great sun. Good thing it's not in art class. They haven't got the sun. The sun's over here. So they're also going to be behind us because they're receiving it much later than us. Yeah, done that back to front. Apologies. Minus has to go that side. Okay, so they're minus because they're obviously behind us and the sun hasn't got to them yet. All right, so that's why whenever it's like, you know, say dinner time with us over on this side of the world, their day is just starting. Okay, because they're minus hours from us. All right, and the sun's only really getting round to them. Alrighty, and that's kind of the essentialness of it. Jay, you asked, does a country, or would the line curve for other countries? Yeah, there's a lot of countries that it will, rather than run straight through it, it will go along the border lines, okay? Which can then cause slight controversies in Europe and stuff where, again, people could live relatively close together, but be an hour apart, but it's because they're in a different country, okay? So if I try and open up the book here, just to see if there's any questions or anything I can see. Yes, it was Portugal. Portugal is in the exact same time as UK, Iceland, and you've got countries in West Africa as well as a continent. Africa, out the west is also UK GMT time, okay, Greenwich Median time. Then you're asking what happens if they meet or they split. They generally won't meet. There are some there that look like they're meeting, but they're actually like almost boxed off zones, okay? So when you're looking at your book, you should be able to see where they originally fall. If you have a look towards +7, so the time zone, which is +7 in your book, as you follow it up, it looks like the times are meeting each other, but they don't quite touch. They go really close, but they won't touch each other. And as a result of that, they fall within that box. Okay, they're all within +7. But it is kind of unusual because in that side, that's sort of like Bali, Southeast Asia territory, Thailand territory. You can see there that there is a bit of a cutoff point. So North and South Thailand actually have different time zones. So that is an example of a country which does split its time inside its own country, which is Thailand. So I think North Thailand and South Thailand actually have different time zones, okay? So the island territory, which is south of Thailand, is on a different time to what is North Thailand, right up inside the country and the countryside. All right. I'm no real idea. It could be also linked to the fact that it's near the equator or something. I'm not really sure why Thailand have decided to do that. It's probably in part to link up with probably a reason to match other people's times. So they're in close proximity to places like Australia and stuff. So chances are they may try and keep their time zones on the same path as them. And then you've even got Australia is also quite an unusual one in the fact that Australia also has different time zones itself too. But again, it's very large, sits in there, and there would be a significant difference going from east to west in Australia. Okay, so that would be another example that I can see. So all it is once you have that, I think question-wise, you should be fine. You find out what time it is somewhere, and then from there, you're trying to work yourself back the time. So you might need a bit of geography skill to find those cities because that map isn't the best. So it'd be made easier if you know your geography. Alrighty. So I said, Phil, if you are struggling to find a place, you might use Google, but if you squint or look really hard, you should find the city name in there somewhere. It should be a better map than it is. And I think it's only questions 1 to 4 that you're doing. Alrighty. And that's about the height of it. It's saying there, like if you're traveling to New York from Dublin and you take off at a time and the flight takes 5, so why don't we work that one through? So if you're taking off from Dublin and let's say it's 12 o'clock, so if it's 12 o'clock from Dublin and you're going to New York and it's 5 hours of a flight, well, 12 o'clock plus 5 hours of a flight brings you to 5 o'clock, doesn't it? So that brings you to 5 p.m. as well. So you're at 5 p.m. However, then if you use your map to find New York, you'll find that New York is sitting there with minus 5 hours. So if our flight took 5 hours, that brings us to 5 p.m. However, then once we're there, then we apply the time zone. And the time zone says it's minus 5. So you take 5 hours back off that time and you end up with 12 o'clock. So you took off at 12 and the place that you arrive, it will still be 12 o'clock. All right. I'm struggling to draw 2's upside down today. So for that type of question, it would be you would end up at 12. It's a bit unusual, and it wouldn't really happen because it's not 5 hours either. It would be a very, very fast flight. Alrighty. So that would be the case. All right. Let's say the ones I've drawn are very wide. They're not as wide as that in real life. Alrighty. So does that help you? I'll do one more then just to see if you get the idea. It's 12 o'clock in Dublin. What time is it at the following places? So again, if it's 12 in Dublin, let's go for New York. New York is minus 5 hours. So if it's 12 o'clock in Dublin, then 5 o'clock or 5 hours off that, if you work it all the way back around, it'd be 7 a.m. in New York. It's 5 hours behind. Okay, so it's 5 hours behind. If it's 12 o'clock in Dublin, what time is it in Bangkok? We just said Thailand. We just mentioned Thailand. So if we go there, we'll find that it is +7. So if it's 12 o'clock in Dublin, it's going to be 7 p.m. in Bangkok in Thailand. Alrighty. Because they're ahead of us. Alrighty. So that's kind of an example on how to do it. And I don't really see any other ones that should take too long. Question 3, it just says, now try these time zone puzzles. If it's 2 o'clock in Oslo, what time is it in Mumbai? When you're doing that type of question, the trick is if it's like that one where you're being based in Oslo and you have to find the time difference. So for example, if I said, you know, it's 3 o'clock in Madrid, what time is it in Bangkok again, just because I can see it. Okay. Well, first of all, it's a bit like our number line game. You find which band you're in. So Madrid is in this +1. Okay. Because that's where the question says you're based, you have to be careful. Okay. So it's +1. You're comparing it to Bangkok, which is over here in +7. Okay. So +1 and +7. Like our number line, you find out what the gap is between +1 and +7. It's 6 hours. So if it's 2 o'clock in Madrid, then Bangkok is 6 hours ahead of it. Calculate it on 8 o'clock, that type of thing. All right. So if you're doing that question where you're being based in a country, you find the gap, the distance between it and the band that you're going to. And if it's say +3 and you're going somewhere that's +8, that's 5 hours ahead. All right. Does that make sense? So that type of question. Try it anyway, and I should be back on later with an answer session. I will do the answer session live, only because the other day I realized that when I'm trying to upload videos, it seems to take hours upon hours to upload a video as opposed to try and get some time. So I realized even if I am a little later, it's much faster to just do a live session and have it up ready for you. Anyway, guys, off you go. Work on through that. You should be fine. As I say, I'll be on Google Classroom if you need me, and I'll put up what time I want to do the answers at. Alrighty, I just need to double check when I can get back on. Okay, so well done, guys. Stay safe as always, and good luck with it. Alrighty, well done.